It should come as no surprise that the key elements in today's powerful hydraulic systems bear so much similarity to the remarkable technology within the human body. The hydraulic pump is much like the heart. The tubes, flexible hose, and couplings are like the blood vessels of the circulatory system. And the hydraulic fluid is like blood, which is filtered by the life-sustaining kidneys. Our interest is primarily in filtration technology, which in the hydraulic circuit removes a whole spectrum of impurities, like the kidneys do. Unlike the human hydraulic system, which under normal circumstances is self-sustaining, man-made hydraulics needs careful servicing and maintenance. 70 to 80% of hydraulic component failures are attributable to contaminant in the oil. Because hydraulic power is often the prime force in big projects, downtime of stationary and mobile equipment can result in large losses and unexpected expense. Besides its destructive effects on the system components, contamination of the oil has other multiple negative consequences. The hydraulic system loses some of its energy and lubricating capacity, as well as its ability to transfer heat, and leakages are produced. This Donaldson training module will provide guidance in proper filter application and contamination control. We know that through clean oil, Donaldson filtration technology will help you reduce loss of production and maintenance expense. The right filtration solutions will lower your cost of hydraulic equipment ownership by reducing component repair and replacement and by extending machine life. We support you with expert technical know-how and prompt customer service. Good filtration also reduces hydraulic oil replacement and disposal costs. As an industry-leading brand, Donaldson has in excess of 1,500 active, issued, and pending global patents, over 1,000 engineers and scientists worldwide, and more than 10,000 employees in 37 countries. Here are just a few design highlights of the Donaldson Spin-On liquid filter, which is made for durability and consistent quality. The Donaldson louvered center tube and spiral lock seam allow more flow area. There is also greater collapse strength, and the smooth surface eliminates wear on the filter pleats. Donaldson has developed and continues to innovate a full line of mobile hydraulic filters for the protection of machinery and components in hundreds of heavy-duty mobile equipment and industrial applications. The Donaldson product lineup includes quality hydraulic filter assemblies, filter heads, replacement spin-on filters and filter cartridges, test points, and reservoir accessories. Let's look into the hydraulic oil holding tank. It's here that most of the contaminant finds its way into the oil. First, it's important to note that new hydraulic oil is not pure. At an approximate ISO cleanliness level of 2119, it is significantly higher, that is, less clean, than OEM standards. This has prompted a leading global heavy equipment manufacturer to recommend filtering new oil before pouring it into the hydraulic tank. Water can also enter the hydraulic system via the holding tank when moist air inside the tank condenses as the outside air cools. Here is a grouping of Donaldson in-tank filtration products for hydraulic systems of various applications and sizes. Looking at this animated hydraulic circuit, note how the oil is drawn through a strainer in the tank, which removes larger debris. The oil then goes onward into the low-pressure pump-protecting suction filter. Low-pressure filters are the most commonly used type in a hydraulic circuit. Donaldson has a broad product line of low-pressure spin-on, cartridge-style, and in-tank filters for solving filtration challenges in virtually any application. From here, the oil, which has been filtered of potentially damaging particulate matter, goes through the inline pump. It is then filtered again in the high-pressure section of the circuit. This second filtration is to protect the expensive hydraulic components, the muscles of the system, from particulate and debris. All of our high-pressure filters contain Donaldson Syntex synthetic filter media, specially developed by Donaldson for high-efficiency liquid filtration. After doing its work, the hydraulic oil proceeds back to the holding tank. It first passes through the medium-pressure return line filter, which removes contaminants generated during component activity. Ideal for medium-pressure application in the circuit is the Donaldson Duramax series. Duramax is well known as the highest-rated spin-on style filter available and is most often used in return line positions. This new Duramax filter allows you to choose between a spin-on or bowl cartridge-style filter without changing heads. The new filter interface makes service easier and provides reliable sealing without having to torque to specification. Its improved performance is a necessity in some applications for meeting ever-increasing system cleanliness requirements. Although cellulose media will suit some applications, others may require Syntex synthetic media in medium-pressure applications. For the same media area, the Syntex media gives a lower pressure drop than the cellulose media due to thinner fibers. Donaldson's highly effective series of breathers is a first line of defense against moisture and particulate in the air. It includes thermally reactive advanced protection, or TRAP breather technology. This is an entirely new technology that begins working faster and provides better moisture protection for hydraulic and lube oil reservoirs. This technology allows only dry air to enter the reservoir as the system breathes in. When the tank exhales during the normal day-night temperature cycle, this exclusive, innovative Donaldson breather technology continuously regenerates breather water holding capacity. This is in contrast to desiccant breathers that require frequent change-out. A brief word about the ISO Cleanliness Code, which is important in determining the condition of hydraulic oil. The ISO 4406 Cleanliness Code uses 3 separate numbers to describe the cleanliness of an oil sample. Measurement is taken of particulate sizes at 4 microns and greater, 6 microns and greater, and 14 microns and greater. The resulting figure, say 18, 16, 13, is the ISO Cleanliness Code level. Suggested ISO 4406 code cleanliness levels have been published. On the stringent side, for example, a 15, 13, 10 code level may be specified for servo valves with very close tolerances. A less demanding 26, 24, 20 would be suitable for low-pressure systems with large clearances. Looked at another way, the dirt in these 3 glass containers each represents a different ISO 4406 cleanliness level, from a tiny fraction of a gram on the left to about 1/3 of a gram in the middle to almost 5 grams of dirt on the right. Note how the 3 cleanliness code numbers also get progressively higher to indicate more dirt and less oil purity. Most component manufacturers specify filtration level recommendations using the ISO code. This code will help you select the filters with the right Donaldson media to meet manufacturer specifications. There's more to know, however, about contaminants which destroy hydraulic components and bring some of the world's largest vehicles and machinery to a halt. Contaminants in the hydraulic system include solid particles such as sand, silt, and metal, solvents, water, air in several forms, and soot. Water in your hydraulic system means trouble. Water is more compressible than oil and has no sealing or lubricating ability and will negatively affect the performance of the hydraulic system. Other contaminants, such as sand, enter the system in various places, such as worn wiper seals. Inadequate breather efficiency also allows dirt to ingress the holding tank. There are situations where offline filtration can be used to supplement existing filtration to achieve target ISO cleanliness levels. For these offline applications, choose from systems such as the Donaldson Turnkey Filter Panel or Portable Filter Cart and Filter Buddy. Analysis of your hydraulic oil is another important part of protecting and maximizing the life of hydraulic systems. Hydraulic oil from equipment in regular use should be sampled at 500 hours or monthly. The Donaldson Hydraulic Oil Analysis Service, which is described in Module L6, includes an evaluating of the test results and specific recommendations and warnings of imminent component damage where warranted. You can also learn how to extend your hydraulic oil drain intervals. This servicing information is provided as a best practices guide. It is not, however, intended to replace or supersede the service instructions supplied by your engine or vehicle manufacturer.